はい、皆さん、こんにちは。Samurai Engineer です。So in this live stream, we will going to discuss singly reinforced T-beam. So we are now on the T-beam. We already have several examples for a rectangular shape. Now T-beam. So let us proceed. But before that, I would like somebody to confirm that we have a clear sound. Okay, thank you, Malsada, for confirming the sound. So let us therefore proceed to the example. So this is our actually problem 4, which is example number 4 actually is from the textbook 2.54 problem. So we have the following given, as you can see. So focus on problem 2.54. So I will show you our manual solution. So manual solution, we copy the given, okay, and then solving it, trying to solve it, okay. So first, always first thing to the procedure is to sketch, okay, showing the crack model. So this is the crack model reflected by the dimension A, and this is our actually the model of the stress diagram. This is our particular stress diagram model. We have the values for the given. So the given reinforcement is 36, so that is exactly equal to 35.8. Area is 1006 times 2. There are only 2 reinforcement, so therefore we have 2012. Okay, so we can solve for the compressive strength from this. We assume that A is right on the flange. It is right on the flange. It does not exceed the value of the flange. So C is therefore 0.85 if C prime AB. Therefore, that is equal to 2012 times rather 0.85 times 28 times 8 times 250. So 0.85 if C prime AB. So if you multiply, that is 5,950 times A. What about the next one? T, ASFY. So we already know AS is 2012 times 350. Okay, so 350 megapascal. So if you multiply, that is 704,200. So therefore we can equate this one equal to this one. Therefore we can solve for the value of A. So, and that would be 118. And because, as you can see from the figure, from the given figure, the flange thickness is 100. And what we found out, A is more than 100. Therefore, our assumption is wrong. Our assumption is incorrect. Okay? The crack model is supposed to be up to the web, not only the flange. So the flange is only 100. This is 180. So let us do the next alternative solution. Okay. So again, let us assume that we have this type of T-beam, and this is now our crack model. This is our crack model right now. Okay. So if that is our crack model, let us. This is already 100. We already know this, but we can let this as, for example, P. Okay, let that one as P. We have this model. Okay, so now our again, this is our T, and we have what? There are two types of uniform stress, because we have the stress on the flange and stress on the web. They do not have the same magnitude. Okay, they do not have the same magnitude, or they do not have the same what? They do not have the same dimension. They do not have the same dimension. So therefore, we can replicate here like this. Let us replicate like this. So we can, for example, say that this is CF and this is CW. Okay. Okay, and therefore we can determine immediately what is this and what is this. So there are two pair of couples. There are two pair of couple forces, couple moment. Okay, so this is the first moment arm, the second moment arm. Okay, for example, Z1 and Z2. Okay, so we can find out the value of Z1. Okay, for Z1, okay. I just noticed that I did not able to show you the previous page. So this is page 1 of the solution. So again, just to be able to show you the manual solution. So this is the given, and then this is our first assumption. We assume the crack model to be like this. The crack portion of the concrete is within the flange web. This is flange web, so the crack model is flange. So like this. So we have the value for total steel area. We have the model. This is the model for what? For the stress diagram. Okay. So and we found out, after computing, we found out that A is equal to 180. This is what I'm saying a while ago. This is wrong because the thickness of flange is only 100. Only 100. This is 180, more than 100. Okay, so this assumption is wrong. Okay, but we do not know if this is really the value of A. So we have to make the correct assumption. So this is the next assumption. So that we draw. from that previous manual computation. So the crack model is now up to the web portion of the TB. Okay, so using this model again, so tensile force. So we have two types of what? The stress on the flange and the stress on the web. So we call it compressive strength of the flange, compressive strength of this portion of the web. Okay, so let us find out what do we find out first. So we need to find out the moment arc Z1. Z1, this is 100. The middle of 100 is 50. So from this point to that point, that is 430. This is 100. From this point to this point, this is 330. Okay? So 430. So this is 430 minus 50. So this is 430 minus 50. Therefore, this is C1 is 380. Okay? So this is in the middle of the flange. So 430 minus 50, that's 380. Okay, next. We have Z2. So we cannot find out Z2 because we do not know P. Okay. So this is actually 330 minus P. Okay. Because from the inside surface, from the inside surface of the flange to the center of the reinforcement bar, this is 330. So 330 minus P, that is from this point to this point. But that is not Z. So this is 330 minus P over 2. Okay? Okay? At the center of this. So at the center of this small portion. Okay? The center is P over 2. Okay? Now, we can multiply. We can find out CF. Therefore, CF or compressive force is 0.85 FC prime times 100, okay, times 100 and times 1,200. And if you multiply this one using our calculator, so let us show the calculator. So this is 0.85 times FC prime is given as 28 times 100, that is 100 times 1,200. So this is 2,856,000. This is 2,856,000. Okay. So that is a very large amount. Okay. And what about CW? Okay. What about CW? CW is 0.85 FC prime, and then we do not know the value of P. So that is P and 250. Is that the 250 is the value of B. So P. So if you multiply this one, 250 equals 28. Point 85, 28 times 250. Point 85, 28 times 250. 0.85, 28 times, so 5,900. 5,950 P. Okay, so what about T? Value of T. This is the procedure. I am showing you the procedure. Okay. So if one assumption is wrong, so we need to do the next one. So another step. So let us find out ASFY. This is what? Given. What is the given FY? Area is 2012 and FY is 350. And this is 2012 times 350. This is 700. This is 700 for 1,200. Now, as you can see, T is going to the right, CF is going to the left, and CW is going to the left. So we can equate. We can equate. There are only three forces. CF, CW, they are going to the left, opposing T, and therefore they are equal. Okay, so therefore, let us write down okay. After writing it down, we can notice that this is wrong. Okay? Okay, so what happened to my what happened? Okay, so there you go. So CF, CW, and T. So CF, CW, and T. CF, CW, they are going to the left. T is going to the right. So we can equate. This is the equation. So after this equation, we can substitute the value. But now, I said, we notice that this is wrong. Why? This is wrong. Because, as you can notice, this is 2 million. This is 704. So if we will find out the value of P, this will transfer to the other side, which is greater than 704, and the answer would become negative. Take note, there is no negative value for P. So meaning to say, this assumption is wrong. But notice, that the previous assumption is also wrong. Okay, so now it is time to reflect. It's time to reflect. What do we need to do after finding out that the two types of solution both are wrong? Okay? It cannot be both wrong. One assumption must be correct. The other must be wrong. It cannot be both wrong. Okay? Because it can either be on the plans or on the web. Okay? It can be either on the plans or on the web. Now, since this is easier, to check. For example, CF. What is the width? What is the thickness? Thickness times width. This is the area. 2 million. Meaning, we must have the value of compressive force in the flange alone. We do not have the value of compressive force on the web. So this is wrong. This must be less than 700. Okay? So therefore, let us go back. Let us go back here and analyze. Analyze further. Okay? So C 0.85, FC AB 0.85, C AB. Okay. We can find out now that the mistake must be this one. Because AB, B is not 250. B is 1,200. Correct? The correct B must be, okay, so we found out the error. We found out the error. The error must be, we have to use 1,200 here. We have to use 1,200 here. Okay? Okay? Because from this point to this point, this is 1,200, not 250. 250 is the thickness of the web, not the width of the flange. Okay? So this is our model. 1,200 is supposed to be there. So therefore, we have to correct this one. So let us correct that part. So edited solution. So the value of C from the first assumption, C must be 0.85 times 28 times A, the width is 1,200. This is the corrected solution. So let us compute that in our calculator. So 0.85 times 28 times 1,200. Okay? So, and that is supposed to be 28,000. This is 28,560 times A. So, and just compute for A. So, therefore, this is T, the value of T, divided by this one. This is 28,560. Okay, so therefore our answer is supposed to be, so our T is 704. 704, 200. Divide by answer, that is our value. So the correct value for A is 24.7. Okay? So 24.7 mm. Okay? That is the correct value. Now, if that is the correct value, therefore we can immediately find out the value of Mn. Mn, therefore, is T times what? D minus A over 2, which is equal to T is 704, 200. D, we already know what is D, 495. 495 minus A, 24.7 over 2. And what is the answer? So let us use our calculator. So 7 200 multiplied by 495. Okay, 495 minus answer divided by 2 equals, this is 339,897,000. So for 3 significant figures, this is equivalent to 340. So this is 340 kilonewton meter. Okay? 3 significant figures. Ha ha ha. This is not our problem. The T. Our problem is T. This is not the one. Our problem is T. So this one. This is problem number 3. Okay. I have the wrong. So I have to do it here. So this is T. So D is 430. So our correct Mn. So our correct value of A is T over 28,560, which is equal to 24.7 mm. So let us do this edited solution. Okay. So from the first assumption, okay. So and Mn, this is the correct problem. Problem number 4. So T is 704. This is 704, 200 So this is not 495 but 430. 430 right here. Yeah. That is D. From the center of this. So I am showing you 495, but this is problem, a different problem. Problem number 3. So this is the correct one is this one. So this is 24.7 over 2. Okay. Here. Okay. This is the. So, therefore, the final answer would be, so let us get back to this. So this is 430 minus 24.7 divided by 2. And the answer would be 294 million. So 294 kilonewton meter. That is our final answer. Okay. So any question? Take note. It is easier to revert back to your point of mistake if you know what you are doing. If you have the correct procedure, it is easier to go back to the step where you made a mistake. That's why it's very important to practice repeatedly so that you can memorize, you can familiarize, your muscle memorize it, the procedure, the step, okay? So that when you encounter mistakes, you can easily revert back to your mistake. Okay, there are no question. So, yung diffuser na nagamit yung poser is from problem 3. Oh, that's why. That's why. That's why we have a wrong answer. Okay. So, I was able to notice it. Okay. So, you should be able to notice it. Okay. So Joshua was able to notice it. So, very good. Okay. Good job. Again, see you after the break. Again, this is Dr. AP, Preaching Engineering for Nation Building.